Section 3-4, present value of an annuity or amortization, is really an important topic for business. And really, for just the general consumer, it is very helpful to know this. Odds are pretty good at some point you might be interested in either buying a home, or maybe you buy a new car, something where you're going to have to make payments. This will give you an understanding of the things you need to be careful about before you agree to a contract to purchase a big ticket item like that. Also, you need to think about how this would also apply in terms of, say, credit card debt. Watch out on what you can definitely fall into with paying just a minimum balance on your credit card. And I think you'll see as you go through this what is really important to be aware of. Now, you will notice our formula has adjusted slightly, and that's because we're not looking for the future value, we're looking for the present value. We want to know what something would be worth right now. Okay? In other words, if I'm making payments over this period of time, what does that mean the value of this is right now when I'm purchasing it? So, here's our formula. Notice one thing that's a little different. Our exponent now is negative. That's going to be very important. Please don't leave that off. If we know the present value and we want to know the payment needed in order to amortize the debt, then we have another formula that you will see here. Okay? All of these terms that are involved are identified for you, but most of them should look very familiar. And so if you want to find the cash value of an item, because maybe part or all of the price of an item is paid off with periodic payments, this will explain how you can do that. The cash value would be equal to the present value of periodic payments plus your down payment, if you had to make a down payment, plus trade-in, if any. You can definitely see how this would apply to, say, purchasing a new car. Now, we're going to talk about Sam's deal here. He makes a deal to pay $400 a month for 3 years on a car loan that's 4.2% annual interest compounded monthly to pay for the car. We're supposed to find the present value for the car. Now, let me just give you a little aside on this as well. My husband sells used cars, and he does not do any in-house financing, but we are oftentimes amazed at some of the people who will contact him wanting to know, does he finance, will you take trade-ins? In particular, one call stands out about a man who had a truck that he was wanting to trade in. He had purchased it about 5 years earlier. He was still making payments on it. His payments were about $800 a month. He'd been paying that for 5 years, and he's still on an original amount, purchase amount of about, I think it was $21,000. He still owed $18,000. It's because his interest rate was through the roof. But here's the issue. If you go in to purchase a car and you are not looking at what is this actually costing me, but you find a salesman and you say, I can afford $400 a month on a car payment, what can I buy? You have made that salesman's day, because I can promise you, you're not going to get a great deal. He's going to be the one that gets a great deal. Now, to calculate what the present value of this car is, we need to use this formula. Present value is equal to PMT times, we're going to have 1 minus 1 plus R over M raised to the negative MT power, and that is divided by R over M. Okay, time to plug in. $400 a month for the payment, The interest rate is 4.2%, so that becomes 0.042, and it's compounded monthly, so our m is 12. Raised to, our exponent is negative, very important, don't forget that. M was 12, and this term on his car loan is 3 years. So T is 3. All of that, when it's been calculated, will then be divided by 0.042 over 12. Now, let me talk you through the calculator entry on this because it does look just a little bit different. Again, I would start with what is inside the parentheses. So if you'll take 0.042, divide it by 12. You can hit enter or equals. Take that answer and add 1 to it so that we've completed everything inside the parentheses. We now need to move to exponent. This has an exponent on it, and the exponent is negative 36. So take that answer you got from the parentheses, raise it to the negative 36 power, and we are now supposed to subtract that number from 1. So you have a choice here. You can either do 1 minus, and then if you have the ability to pull back this answer in your calculator, if you're on the TI graphing calculators, after you hit 1 minus, if you'll hit second and the negative sign, it will do it for you and keep all those digits. If you want to write down all the digits and type them in, you can. Here's the other option. You could take your answer and you could hit the negative sign possibly to turn it into a negative number and then add 1 to it. It depends on the way your calculator is structured. So you've got to complete that entire numerator before you divide it by the 0.042 divided by 12. And again, don't forget that needs to be in parentheses as well. Take that answer times 400, that'll be your last step, and you will have $13,507.56. Now, that's good to know, because if you're purchasing a car, and let's say this is a used car, you can go to Kelley Blue Book online or some other online app that will tell you what a car is worth. And if it turns out that this car that you're going to pay $13,500 for is actually only worth about $9,000, you need to walk away from the deal. So make sure that you understand whether you're getting a good deal or not. Now, let's also check and see what kind of interest Sam is having to pay for this car. So we need to know how much Sam is going to be making in payments for the car. Well, if he makes his payment at $400 a month for 12 months for 3 years, if we multiply that out, he's paying $14,400. So can we tell pretty easily how much interest he's paying on the car loan? Absolutely. If we will subtract the amount he's actually paying minus the present value of the car, we'll find out that he's paying $892.44 in interest over the 3 years. So that will give you the information, hopefully, to be able to make a good decision about whether that's the car to purchase or not. Now, a car dealer who's going to charge interest at 5.5% compounded monthly offers to sell you a new car if you trade in your car, which is worth $6,000, and you agree to pay $350 every month for the next 3 years. So this is the deal that he is offering. Well, we want to figure out what would be the cash value of that car today. So we use the same formula that we just used a moment ago with one little difference. So let me copy this down. That's going to be the amount that he pays, but remember, he's giving you a trade-in on your car. So your trade-in has to be factored in to the value on this car that you're buying. Okay? So you're going to pay $350 a month. We're going to fill in 1 minus 1 plus. We've got 0.055 compounded monthly, so that's a 12. Raised to the negative 12 times, you're doing this for 3 years, so your time is 3. Plus, don't forget, your car that you're trading in is worth $6,000. So if we calculate this, your payments that you make have a value of $11,590.98. That would be the present value of those payments, plus the $6,000 for your trade-in brings the value of this new car to $17,590.98. Now, depending on the car, that may be a good deal. It might not be a good deal. But we can calculate the amount of interest that you would be paying with this deal if we do what? If we actually multiply out what those payment amounts would be over the 3-year period. So if you're paying $350 a month for 12 months for 3 years, that means you have paid in $12,600. Now, the present value of those payments was $11,590.98. So you have actually paid $1,009.02 in interest. So when we take the total amount that you've paid minus the present value for those payments, that's how we can see what the actual interest amount is. All right, so if you're a smart shopper, you don't necessarily go with the first deal. You talk to another car dealer. He's only going to charge 4.8% interest compounded monthly. And he tells you that if you'll trade in that car, which is also worth $6,000, pay him an additional $1,000 down and pay $400, but only for 2 years. He'll make that deal with you. Now, let's see what the cash value of the car today would be. So again, we're calculating present value. And that would mean, because our payment amount is $400, we're going to have 1 minus, now that interest rate that he's offering is 4.8%. So that becomes 0.048. But it's compounded monthly, so that's divided by 12, raised to the negative 12 times, this time you're only paying for 2 years, divided by 0.048 over 12. Now again, don't forget, you got to add that $6,000 for your trade-in. And you have a down payment that he wants of $1,000. So you've also got another $1,000 that you're going to be paying. All right. If we calculate what's in the parentheses, and again, we've talked numerous times about order of operations and having good calculator skills. Once you get all that calculated and you multiply it times 400, you should get $9,136.20. But then we still have to add the $7,000 between the trade-in and the down payment, and that will give us a value of $16,136.20. Now remember, we're comparing that to this value up here of $17,590.98. If you look on the surface, where's your better deal? Well, I think it's safe to say that the second car is actually a better buy, but there are other things we should consider. So let's go to the next slide. And let's actually calculate how much interest you would pay with this deal. So you're going to be making a little higher monthly payment. That's $400 times 12 times 2. So that's $9,600. And if you remember, that present value on those payments was $9,136.20, which means you're only paying $430, looks like, what would that be? $433.80 in interest. That's not very much in interest. So if you had to explain what's the better deal, can you do it? Now, realistically, there are pros and cons with each one, okay? So I think you could say problem 3 is the better deal in that you are paying less interest and a lower amount for the car, right? However, it does require a higher monthly payment. That might be a problem for you. And an additional $1,000 in down payment. So there are factors to consider here. If you can't afford the extra $50 a month and you don't have the $1,000 to put down, then you might need to go with the first option. All right, Mark and Natalie want to buy a house selling for $120,000. They will put $20,000 down as a down payment and finance $100,000. So if the bank is offering a 30-year mortgage at 5.4% annual interest compounded monthly, what will their monthly payment be? Okay, to calculate the monthly payment, we need that second formula from our sheet. We're going to have to take the present value, multiply it times R over M, times 1 minus 1 plus R over M to the negative MT power. You'll notice parts of this look very familiar, but this has to be raised to the negative 1 power. Now, as we get ready to calculate this, here's what we'll put in. The present value is the amount that they are actually financing, which is $100,000. The interest rate, 0.054, and that is an annual interest rate compounded monthly. M is 12. All right, now we get to the big messy one. We have 1 minus, in parentheses, 1 plus 0.054 over 12 raised to the negative, M is still 12, but they're going to finance this for 30 years, so T is 30, and this has to be raised to the negative 1 power. All right, don't let all of the parentheses and the exponents and the negatives confuse you. We're still going to go through and calculate this the way that it's laid out. So start with the inside parentheses, 0.054 over 12, and then add 1 to it. Before you do anything else, notice you have to take care of the exponent, which is the negative 12 times 36. Oh, I'm sorry, I put 36 there. That's supposed to be 30 because it's the 30-year note. So the negative 12 times 30, which is a negative 360. So just to make sure we're on the same page, the 0.054 divided by 12 gives you 0.0045. You're going to add 1 to that. So you have 1.0045. You need to raise that to the negative 360 power. And that is going to be 0.1986, da 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 da. If I subtract that number from 1, and I would encourage you, keep as many of these decimals as you can, you're going to have 0.80138, da 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 da, but that has to be raised to the negative 1 power. Notice this right here. That applies to everything that's in this parentheses. So we're going to raise that to the negative 1 power, and it turns into 1.2478 and so forth. Now multiply that times, in parentheses, put your 0.054 divided by 12, and then you can multiply that times 100,000. And that should give you a monthly payment of $561.53 when it is rounded to the nearest cent. That is how a mortgage company will calculate what your monthly payment needs to be. And when you purchase a house, they give you an amortization schedule that shows out of this amount that you're paying every month, what would apply toward interest and what would apply toward principal. Now, just kind of in case you don't understand this, here's something that's important to know. Early on in this mortgage, if it's a 30-year mortgage, out of this $561.53, almost all of it is going toward interest. There is a very small amount that would go toward your principal that you owe. That's why if you can pay extra on your payment in the early part of your mortgage, it can make a huge difference in taking time off the end of your note. So if you can send in an extra $100 or $200, then you're going to find that you can take a number of years off of your note because you're applying so much extra principal in the beginning. Now, if these people don't do that, they just make all of their loan payments on time. Let's see if we can find out the amount of interest that they will be paying. So $202,150.80 is what I get if I multiply 561.53 times 12 times 30. That's the total amount they have paid. If we then subtract the $100,000, which was the amount they were financing, they have paid $102,150.80 in interest. They have paid more in interest than the amount that they borrowed. Now, you may be thinking 5.4% for a mortgage right now sounds high. At this moment in time, it is a little on the high side. But let me tell you, when I bought my first house, my husband and I, when we first got married, this was back in the 80s, and interest rates were double digits. I mean, you were fortunate if you had a mortgage that was at 13% interest. And it makes a huge difference in how much house you can afford. So keep an eye on those interest rates and make sure if you're purchasing a big ticket item like a house or a car, you get the best interest rate you can. All right, Wake and Elizabeth are buying a $130,000 house, and they want to put 15% down. The bank is offering a 30-year loan at 7.74% compounded monthly. Poor Wake and Elizabeth. Let's see if we can find what the loan amount would be. Well, if the purchase price is $130,000 and they're going to put 15% down, then we would subtract out 130,000 times 0.15. That's going to be the amount that they're putting down as a down payment, which means they're going to finance $110,500. What will the monthly payment be? All right, we just used this formula a minute ago. Let's see if we can do it again. So our PMT is equal to PV times R over M times 1 minus 1 plus R over M raised to the negative MT power, and that entire parentheses gets raised to the negative 1 power. So we're going to take this present value of $110,500. Our interest rate is 0.0774 over 12 because it's compounded monthly. And then our big parentheses is 1 minus, see if I can get my parentheses to look right there, 1 plus 0.0774 over 12. That's got to be raised to the negative 12 times, and it's a 30-year loan. That's a negative 360. I just went ahead and multiplied the 12 times 30. And then all of that gets raised to the negative 1 power. All right, it's time to put this in your calculator. Since I walked you through step by step on the last one, I want you to see if you can do this on your own. If you want to pause the video for a moment while you do that, you can. And the amount of the payment you came up with should be $790.87. So can we calculate the amount of interest paid during the term of the loan? The answer is yes, we can. We just have to take that payment amount, $790.87, multiply it times 12 times 30. They're going to have paid $284,713.20 if they make all their payments on time over that 30-year period. If you subtract out the $110,500 that they started with on their loan amount, they have paid $174,213.20 in interest. Way more in interest than the amount that they borrowed. And again, a big part of that has to do with the interest rate. So please shop around for a good interest rate. It is really important. Now let's look at how you can actually build an amortization schedule. Margaret is going to buy a new stereo. She's going to spend $500, but she needs it financed. So the store agrees to finance it for 4 months. They're going to charge her 12% interest compounded monthly. Now, the way this works is her monthly payments will be in equal amounts, with the one exception being her final payment. It won't be more, but it could be a little bit less than what the other payments are. And I want to go through and show you how you can calculate this. It's all based on this little formula we used earlier in Chapter 3. I equals P times R times T. So let me show you, since this first line is already filled out, let me show you where these numbers came from. At the start of the month, she owes $500. We know that she's been told the amount of her payment will be $128.14. Now, you probably wonder, how do you know $5 is interest? Well, that's because if we plug in the $500 that she owes at the beginning of the month, she's being charged 12% interest, so we have 0.12. Now here's where you have to think for a moment. The amount of time that's going to pass before her payment is made is 1 month. Remember, time has to be expressed in years, so that's 1 over 12 for time. If you multiply that out, you come up with 5. That's why her interest that's due at the end of the month is $5. So the principal that will be due at the end of the month is the difference between the amount she paid and then you subtract out the amount that was interest. So she will still owe $123.14 of that payment went to principal. And if that is subtracted from 500, so we took 500 minus 123.14, that's how you get 376.86, which would be her remaining balance after her first payment. All right, so we're going to fill in 376.86 for her balance at the start of the month. Do we know the amount of the payment? Yes, we do. She's going to pay $128.14. Now, I need to calculate how much of that payment is going toward interest. So again, I go back to I equals P times R times T, but this time my P is 376.86. Interest rate is still 0.12, and time is 1 over 12. If I multiply that out, I get, rounded to the nearest penny, $3.77. Now, if I take the 128.14 and I subtract the 377 from it, that would give me $124.37 that is applied toward the principal. Okay, so out of the $128.14 she paid, $124.37 goes against her debt, which at the beginning of the month was $376.86. So if you'll take $376.86, subtract the $124.37 from it, $376.86 minus $124.37, you will come up with $252.49. Okay, so after 2 payments, that's how much she still owes on her stereo, which means at the beginning of the month, $252.49 is what she owes. All right, let's figure out what happens on this third payment. Again, $128.14 is what she's paying. Let's see how much of that is interest. $252.49 is her principal, times 0.12 times 1 over 12. That's going to calculate to be $2.52. Now notice each month the amount that's going toward interest is going down. That's not accidental. If I've got a lesser amount that I am paying interest on, I'm going to be paying less in interest. So $2.52 out of that $128.14 is interest. If I subtract those two, that will tell me how much gets applied toward principal. And that's $125.62. $125.62. So to determine what the remaining balance is at the end of the third month, after she's made that third payment, if I take my $252.49 and I subtract the $125.62 from it, that's how I'm going to come up with $126.87. Now you may be thinking, well, that's got to be the last payment. No, because if I'm not going to pay it until the end of the month, I'm going to have to pay interest on that amount. Now, before I write in the amount of this payment, I need to see on that $126.87 how much of that would end up needing to be paid in interest. So let's see what happens if we take 126.87, we multiply it times 0.12, and then multiply it again times 1 over 12. Put that in the calculator. Let's see. Give me just a second here. And I'm coming up with $1.27 in interest. Okay, now here's where you got to be careful. In order to get the amount of payment, I will need to add these two together to know what that final payment is. Now, it turns out, coincidentally, that it is exactly $128.14. It will not always work out that way. It just so happens that those two added together will give me the $128.14. And since I had $126.87 as the principal that was due at the end of the month, if I take $128.14, subtract $127 from it, that's what I get. I now have a zero balance. Okay, it's not hard, but it is a little time consuming to go through all these steps. Okay, so now we have a student who wants to buy a computer. It's $2,400, and the price will be amortized at 15% annual interest compounded monthly. That is a really hefty interest rate to pay. And it will be paid back in 6 equal monthly installments, or approximately equal monthly installments. Now, one thing different, they're not telling us what the monthly payment amount is. We're going to have to calculate that, but we can do that because we have our formula that we used on the last problem. We can find the payment if we take the present value times R over M times, and then we have this big parentheses, 1 minus 1 plus R over M raised to the negative MT power, and that whole parentheses is raised to the negative 1 power. Now I'm going to show you, if you plug in, the $2,400 is what we're borrowing. The interest rate is 0.15, and it's compounded monthly. So that's a 12. Then this parentheses is 1 minus 1 plus the 0.15 over 12. But we have a negative, m is still 12. And be careful, remember t has to be in years. Since I'm only doing this for 6 months, that's half a year, 0.5. And then this entire parentheses gets raised to the negative 1 power. Now, I'll walk you through this one more time, just to be sure that you're okay with your calculator entry. You want to start by taking 0.15, divide it by 12, and you're going to have that number plus 1. And you should have 1.0125. Okay? Now, remember, that's got to be raised to the negative, and then we're going to multiply 12 times 0.5 for our exponent. And we have 0.92817, da-da-da-da-da. That number has to be subtracted from 1, which gives us 0.071825, da-da-da-da-da. Raise that to a negative 1, and we have now taken care of all of this. And I have 13.9227. That gets multiplied by, I'll have to put the 0.15 divided by 12 in parentheses, and then take that and multiply it times the 2400. And I am coming up with a payment amount of $417.69. Okay? So now that I know the payment amount, just as we did before, we're going to have to calculate the interest that is due at the end of the month. So on this first payment, my $2,400 gets multiplied times my interest rate, which is 0.15, times my time, which is 1 over 12. And I'm coming up with $30 is the amount that's going toward interest out of this first payment. Now remember, if I'm paying $417.69, and if you take out the $30 in interest, that tells me the amount, excuse me, that would be applied toward principal at the end of the month. And that's $387.69. So if I take my starting balance, which was $2,400, and I subtract the $387.69, I come up with $2,012.31 is my balance at the end of the month, which means that's the amount that I'm starting with at the beginning of the next month, $2,012.31. We go through the process again. Now, I'm going to make that payment of $417.69, but I need to calculate how much will go toward interest. So my starting balance was $2,012.31 times 0.15 times 1 over 12, and I'm coming up with an interest amount of $25.15. So out of that $417.69 payment, if you subtract out the interest, that means at the end of the month you have $392.54 that gets applied toward the principal. And if I would take the $2,012.31 that I owed at the beginning of the month, subtract out this amount of principal, $392.54, that's going to give me a balance of just a second, I'm having a hard time getting my pen to write. There we go. $16.19.77. At this point, you may want to pause the recording so that you can calculate the rest of the table. I will pick back up with you in just a moment. And so you can see on payment number 3, 4, 5, I have filled in the values. Let me just kind of hit some high spots with you so you can make sure your numbers match up. On payment 3, you should have $20.25 paid in interest, which means $397.44 was the principal due at the end of the month, leaving you with a balance of $1,222.33. On payment 4, you would have had $15.28 in interest, which would mean $402.41 of that payment amount went toward principal, leaving you with $819.92 as a balance at the end of the month. On that 5th payment, $10.25 went toward interest, which would mean that $407.44 went to principal, leaving you a balance of $412.48 at the end of the month. Now, let me walk through this last row with you. So you have $412.48 that is due at the beginning of this 6th month. So what we have to do is calculate the interest amount. We have $412.48 times 0.15 times 1 over 12. If you multiply that out, you're going to come up with $5.16. That's the amount of interest that's due. Now remember, you have to add these together to see what the amount of the payment is. So if I take that $5.16 and I add the $412.48 to it, I get $417.64. Just a little bit less on that last payment. And that would mean out of this payment, when I subtract the interest, $412.48 went toward principal, leaving me a balance of 0. It's not difficult to do the amortization schedule, but it is pretty tedious. So how much did the student actually pay for the computer? In other words, let's figure out what the starting balance plus all the interest added up would be. So what we know, if we look at this table, we're going to have to take this column right here and total it up. So you want to add 30 plus $25.15 plus $20.25 plus $15.28 plus $10.25 plus $5.16, and I'm coming up with $106.09. So they started with the $2,400 debt plus the $106.09 in interest, means the actual cost of the computer was $2,506.09.